the meanwhile. So we can start. Okay. So anyone wants to take up the first problem? I think Kaushik should take up, like if he has done. Otherwise, Gaurav will take it up.
Actually, I did wrong and
Okay.
I did not understand the question well.
Gaurav, you
So
can
I
take
can't.
that up. First one, Gaurav. Second one, Arnab did that. So Arnab. Third one, Diptiman can explain. And fourth, I will explain.
Yeah, sure. Just give me a second.
Sure.
Yeah. So should I share it like once?
Yep, you should share
Share.
the screen and we discuss three things: explaining the problem statement, explaining the algorithm, and just telling it how why it works. And just
Yeah,
a
sure.
bit of on the how do you implement the algorithm.
Yeah. Just give me a second.
Sure.
Uh, there's some issue going on with sharing screen.
Okay. Just okay. So I will take this up. Like it's a easy problem. So it says that
Yeah.
you have n and
Can
k.
you just share your screen? Then I'll explain. Uh,
Okay. Okay.
the
Makes sense. Yup. You can go ahead.
Yeah. So the question statement says that we are given two positive integers n and k, right? And we have to choose. There's a operation we have to perform. We can choose any bit in the binary representation of n that is equal to 1, and then change it to 0. And then we have to return the number of changes needed to make so that n becomes equal to k. And if it's not possible, then we have to return -1. It's like a brute force. We will just iterate over the bits of the number, and the base case would be if n is smaller than k, then we will return -1, and it won't be possible.
Diptiman, yeah.
Sorry.
Hello, Anish.
Hmm.
Are we discussing the weekly or the bi-weekly?
Bi-weekly.
Acha, but I think this is the weekly one, I guess.
Uh, okay. No, I think this
I
one
think.
should be of bi-weekly, right?
No, I guess this is weekly.
Okay.
Yeah.
So I think we can discuss weekly then as we have started. Okay. Tomorrow we will discuss bi-weekly then. Sorry. Yeah, that's a thing. Like, thanks for
So,
pointing
but
out.
I didn't actually I didn't do the weekly one.
Let's
Yeah.
discuss. Let's see the problems today.
Okay,
Maybe
okay,
you can
okay,
go
fine.
back and always discuss about that. Okay.
Okay.
Yeah, Gaurav, go ahead.
Yeah. So the explain the question. We have to just perform an operation that if the bit if nth or kth bit of the number n is equal to 1, we can change it to 0, and we have to return the number of operations we will perform to make n equal to k. And if it's not possible, then we will return -1. So this is the problem statement. The base case is will be key. Agar n is smaller than k, then it won't be possible because we can't
Hmm.
perform 0 to 1, but we can perform 1 to 0.
Like anyone has any questions, or otherwise I will take this up and explain. Anyone, like, otherwise we will quickly move to the second question of weekly.
Uh, Please explain here.
Okay. So they have told that they have two numbers. One is k, and another one is n. Okay. So they are telling that if we represent k in binary, let's say if it is 1 1 0 0 1, and let's say n is 0 1 0 0 0. Okay, so you can take every bit and change that bit to uh, 0. Okay, like if a bit is 1, you can change it to 0 of k. Okay, so you have to find the number of operations needed to perform to change k into n. Okay, so it's very simple. You first convert k into binary, you convert n into binary, and check that whether and check how many bits are such that in k it's 1 and in n it's 0. Okay, so if the number of bits where uh, in k it's 1 and in n it's 0, we have to change those bits. Okay, now let's say if there is any bit where for k it's 0 and for n it's 1, then it's not possible. Okay, because we can't change 0 to 1. Okay, so first convert k into binary, then convert n into binary, and then check that whether in k if it is 1, in n it is 0 or not. If it is, then add 1 to the answer. If it is same, we don't need to do anything. If in k it is 0, if and in n it is 1, we simply return -1 without any further checking. Okay, because this operation is not allowed. Clear?
Clear, clear.
ठीक है, तो second one, अर्नब.
Yeah, please do share the screen. Second one. Okay, so this one. So first I'll try to explain the question. So basically we are. So we are given a string s, and basically there is a game, and we are given a string, and two players playing the game. First, Alice and the Bob, both two are playing the game. So in the turn of the Alice, she has to remove any non-empty substring from the S that contain an odd number of vowels, and for the Bob turns, it has to remove any non-empty substring from the S that contain an even number of vowels. So we have to find out that who will ultimately win. So if we observe clearly that if any of the vowel is containing the input string, then always it will be the allies who will win. Otherwise, if it doesn't contain the any vowel, then I mean another player like Bob will win. So when the Bob will win, we will return false. Else we will return the else. So so basically we can simply iterate the string, and we can check whether is it vowel or not. If any character of the string is contained vowel, then we can return the true. That means the Alice will win. Otherwise, we return the false, and then the Bob will wins.
I think, was it understandable? Like those who didn't solve, did you get the logic?
Get
Guys,
it, get it.
Kaushik, Tarun, Aniket,
Yes, I get it.
others.
No, sir.
ठीक है, and others.
I have just joined.
Cool. So I will just tell it that let you are given a string, and there are two players, Alice and Bob. Okay, so what Alice can do in his turn is that he can remove a non-empty substring where there are odd number of vowels, and Bob can remove a substring which have even number of vowels. Okay, so it's very simple. Let's say this. Let's understand how the parity changes. Okay, so let's say the string s. Let's say there is a string s. some letters are there like A, C, D, E, dot 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 dot. Okay, so let's say there are n number of vowels. Okay, or let's say there are x number of vowels. Okay, so if x is 0, let's say if there are no vowels, so in this case Alice is moving first, so Alice can't make a move, right? If there are no vowels, so Alice will lose and Bob will win. Okay, so if there are no vowels, we return false and we are making Bob win the game. Okay, so this is the base case or the corner case, you can say. Clear? Come on guys, yes or no?
Yes, sir.
Okay,
It's clear.
now let's
Yes.
say if x is not equals to 0. Now let's come to the thing. If x is not equals to 0, so Alice will move first and Alice will remove a odd number of vowels. Okay, so now there can be two cases, x is odd and x is even. So now let's take the both cases, x is odd and x is even. Okay, so first he moves it. Okay, so let's say that he has even number of strings. Okay, so if I remove a odd number from a even number, how many what should I say, how many would it be, even or odd?
Or
It will be odd. So after Alice's move, it will have a odd number of strings. Okay, so even if the number of strings is even, after Alice's move there will be an odd number of vowels left. Now comes the turn of Bob. Okay, so he will remove a even number of strings. Okay, so if I remove a even number from a odd number, will it be even or odd? So I am removing an even number from an odd number. Will it be even or odd?
Odd.
Odd. Okay, so now Alice will move and he has odd number of strings, so he can remove the whole remaining string and he will win it. Okay, so for even, Alice is winning by this method. Now if there are odd number of strings in the beginning, Alice will remove the whole string and he will win. So in case of both odd and even, Alice is winning. The only case where Alice will lose when there are no vowels and he can't make a first move. Okay, clear?
Why he can't make the first move?
Let's, if there are no vowels, he can't remove anything, right?
Okay.
Because he has to remove a odd number of vowels. So if he can't make the first move, he is losing the game. Otherwise, let's say if he can make the first move, in case of even number of vowels, it will flow like this, that first he will move a odd number of elements, then it will have odd number of vowels, then Bob removes the even number of elements, and then he removes the full string. Okay, in case of odd, he removes the full string in the first go. Okay, clear everyone?
Yes.
yes,
Great.
Yes.
Now let's go to the third one. Diptiman hasn't done it anyway. Okay, so let's understand what the question says. Anyone has done it, by the way? Gaurav has done it.
Yeah, I did it.
Maybe try to explain, and Gaurav, while explaining, make sure that you, when like most of you try to explain the implementation part, that I will do this, I will do this, I will do this. While explaining, you shouldn't explain what you should do. Explain why you should do the certain thing, like why should be more important than what you should do.
Oh, okay, got it. Yeah. So the question says we are given a binary string. So and we have to perform some operation. The operation is we have to choose any index I where the condition of the index I is I plus 1 should be less than s dot length, which basically means we cannot choose the last index, and that's it. And there is one more condition, that the index the bit at or the character at that index should be 1 and the next character should be 0. Basically, we can choose a substring 1 0 and we have to move that character with the 1 to the right until it reaches the end of the string, or we have found another one. Basically, we have to just push the 1 to the, we have to stack all the ones together. That's in short term I can say that. And we have to return the maximum number of operations we can perform in this string. Is the question clear?
The question is clear, right?
Yeah.
Yeah, let's go
Yes.
ahead.
Yeah. So the very first approach that came to my mind, or what I did, was greedy. Obviously, and a 1 in the string can only move if it is immediately followed by a 0. So when a 1 moves, it continues to shift right until it encounters another 1, or it reaches the end of the string, right? So we can just track how many ones are to the left of each 0, and then each 0 encountered allows all previously counted ones to move past it. Basically, we can iterate through the whole string while maintaining a count of ones. Whenever a 0, we find a 0, we can add the current count of the ones to the total number of operations. So, and we can skip over consecutive zeros until the next one is found, and then we can return at the end of the string.
Okay, I think the explanation was better. Anyone has any questions, like, or I will just try to visualize that. Come on, guys, like, yes or no. Every time, like, I shouldn't ask that whether I've understood or not.
Please proceed.
So let's say this is a string, okay. So in one operation, I can swap, like, bring this one to the 1, just to the 0 just before the next one, okay. So in one move, I can make it 0 0 1 and then the 3 ones, okay. And then there is 0 0 1 1 0, okay. In the next move, what I can do, I can bring this one here, okay. So the question tells that my final state should be all the zeros in the beginning, okay, and then all the ones at the end. This should be my final state. How many operations should I perform? Okay, now it's very simple, that let's say I have to calculate the group of ones. So the first group of 1 has only one single one, the second group has 3 ones, and the last group has 2 ones, okay. So for moving the first one to the group of 3, how many operations I have to do? Only one operation. I just have to move the single one to this 0 before the second group, and I will have a combined group of 4, right? So I would add 1 to the answer, okay. So now what is my groups after moving the first one to the second group? I have a group of 4 and I have a group of 2, okay. So now to move these 4 ones to the group of 2, how many operations I have to do? 4 operations, 1 for each one, right? So I have to add 4. And after adding 4, I would have a group of 6. So it will look something like this: 0 0 0 0 and then the 6 ones, 1 1 1 1 1 1 and then the last 0, okay. Now I have to move these 6 ones to the last, okay. So it will take another 6 operations, so it will be plus 6, okay. So this will be my answer. So I would need a total of 11 steps, okay. So basically how you do this is, like, first you add 1, then 1 to the answer and 1 to the next group as well. So your array becomes 4 comma 2, then you add 4 to the answer and also 4 to the next group. So your now only group is 6, so you add 6 to the answer and now you have all the ones at the end, okay. And one more thing you have to consider, that let's say if there are some ones at the end, so if there are some ones at the end, so you don't have to, like, worry about those, because those are already at the end. So forget about the ones which are at the end. You can simply trim that off and consider the string from the last 0. Okay, so you can, so your string of concern is removing all the ones at the last. Okay, and then performing the algorithm I just told. Clear?
Clear.
Okay.
Yeah, clear.
Fourth one, anyone did it like weekly? I am not very sure why LeetCode is giving so many of segment tree concepts. I also am not sure that if it can be solved without using segment tree. But did anyone read the question before this? Okay, so the question says you are given two arrays. One is nums and one is target. You have to convert nums into target array. Okay, so what operations you can perform? You can select a sub array and you can either add one to each element in the subarray or subtract one from each element in the subarray. Okay, so for example, if you have, let's take the first example, 3512 3512, and here you have 4624 4624. Okay, so let's say if I select the whole subarray and add one, what will be my array? My array will be 4, 6, 2 and 3, right? Then I will select the subarray of the last element and add one more. So my array becomes 4, 6, 2, 4. Okay, so now I have got my target array. So the number of operations needed is 2. Okay. Yep, Arnab say.
So I have a doubt. I mean, the relative position should be the same, or the position can be different.
No. You have to convert the same in, means you have to convert the first element to the first element in target. You have to convert the second element of nums into the second element of the target.
Okay,
It
got
has
it.
to be
But
the
where it is mentioned in the question, like, how do you know?
Yep, like it's mentioned, na, like you have to convert nums equal to target. Like when it's
Okay,
telling that an array should be equal to target, it means the indexes also should match. In
okay,
cases of dictionary or in cases of sets, you could have said that the means the number or the combination of the elements should match, but in an array the indexes also matter.
okay, got it.
Okay, so this is your question is clear to everyone?
Yeah.
Great. Let's move to the implementation. Okay, so let us reduce the question to another question. Okay, so if the nums array is equal to the target array, so the differences in the indexes should be all 0, right? Like if I make an array nums I minus target I, it should be 0 if I convert nums into target, right?
Yes.
So our goal is to make a difference array containing nums I minus target I and then convert all the elements in that array to 0. So if I make the difference array for this one, it will be 1, it will be 1, 1, 1 and 2. Okay, so I need to convert these 4 into 0. Okay, so first I have to divide, so first I have to make this difference array. Okay, and let's extend this example so to understand it better. So let's say there is 5 and there is 4. Okay, one more element in the example, so the last element will be -1. Okay, so the first observation that you have to make here is that in these subarray, like when you are considering a subarray, you have to consider the subarray such that all the numbers in the subarray is either positive or it's negative. Okay, so when you are taking a subarray, like you have to ensure that all the elements in the subarray is either all positive or all negative. When you are taking all positive, you can't include a negative number or you can't include 0 in that subarray. Okay, So for example, I can take the subarray of the first 4 and I can take the subarray of the last one. Okay. So let's make a function. Okay, or let's say that, so now our operation is divided into two parts. So I have to make this array 1 1 2 into 4 zeros, and I have to make -1 into 0. So for -1 into 0, I simply need one operation where I will increment this -1 by 1 and I will make it as 0. So it will be +1, like it will require one operation to make this subarray to 0. Now how many operations this subarray will require? It's very simple. It will require two operations.
Two operations.
Okay. So first we will take this subarray and we will we will first take the whole subarray and decrease it by 1. So now our subarray is 0 0 0 and 1, right? So if I follow the same algorithm which I just told, that I will take a subarray every time with either all positive elements or either all negative elements. Okay. So I will take this subarray which has a positive number. So I will decrease it by 1 again. So it will become 4 zeros. So I need two operations to convert this into 4 zeros. So it will be 1 plus 2, 3 operations in total. Okay. Till here it's clear?
Can you explain the last one?
Last part, which one?
The whole array subarray becomes 0. How it becomes?
So basically first I am taking the whole subarray and decreasing it by 1. ठीक है? So like it becomes 0 0 1 0 0 0 1, right?
Okay.
Now I will decrease 1 with the last element only.
Achha. Only last element.
Because the other ones are already 0 and like there is no point in including them in the subarray.
Okay, got it. Then I can take the whole array, either any single array. Subarray.
You can take any subarray. You can also take like 1 1 and 2 also.
Okay, got it.
Any subarray you can take. I am telling the optimal subarrays that you should take in this example. Okay. Now let's take another example. So let's say the difference array is 2 1 2 -1 and 2. So someone tell me how we should divide the array and go about the algorithm which I just explained. So first, what will be the distinction of the arrays or the division of the arrays?
First we can group like first 3 element 2
Okay.
1 2.
Okay.
Then we can group -1 and then +2.
Okay, great. So for 2 1 2, how would we go?
Like we can decrease by 1, like 1
And-
0 1.
Okay, 1 0 1. So we will take the whole subarray.
Yep. And then in the -1 we can add +1.
Okay, it becomes 0.
It becomes 0, and then again -1. Then it becomes +1.
Like it's already 0, right?
No, I'm telling about last group, like 2.
So it will have, it will
Minus
become 1 and then it will become 0. So we can write directly 0 because we can subtract any number of.
Not any.
Sorry, we have to
Subtract by
decrease by 1.
yeah.
Okay, so so it will be in 2 operations. Yeah, correct. And here again.
Again, we can group it by 2, like first one and last one.
Okay,
so first one decrease by.
So it will have 1.
First one
0
and last one.
And 1. Okay.
Yeah.
So this one you can make it as 0. This one you can make it as 0. So the operations is 1 here. 1 you are doing it here. So 2, 3, 4, 5, 6. Right? 6 operations.
Yeah.
The algorithm is clear till here.
Yes.
Others?
Yeah.
Great. So how can we program this algorithmically? What have you observed here? So let's take another example. Let's say instead of 2 1 2, let's say there is 3 2 3. Okay. So what will be the steps here? So first you make 2 1 2, right? Taking the whole subarray. Then you make it 1 0 1, right? And then you follow the same order. Okay. So what observation do you make here? Yep. Tell Aniket.
I have a doubt that array you have presented, can't we sort it first, then we perform the operation?
Why do you need to sort first? You can't sort. You have to match the indexes as well.
Okay, okay, got it.
Like every respective index should be equal to like that respective index in the target array. The first element in the nums array should be equal to the first element in the target array. You can't change the indexes. That's what I clarified in the first go when Arnab asked that question, that is it index wise or not. Okay, so the observation that you are making it here is that what's the minimum element out of 323? It's 2, right? So decrease 2 from all the elements first. So if you decrease 2, you get 101. Okay, so in the answer, so when you have a sub array, find the minimum element, which is 2 here, add 2 to the answer. Okay, so add 2 to the answer and decrease all the elements in the subarray by 2, so it becomes 101. Now divide that subarray into two halves. The first half will be from the starting till before the smallest index, and the second subarray will be from the next element of the smallest element till the end. Okay, so let's take a, so if I have the subarray as like 3 2 3 4, okay, so I would first decrease 2 from every element, so it will become 1 0 1 and 2. Okay, so when the smallest element has become 0, so now I have to divide this into two subarrays or subgroups. Okay, so I would take this one out and I will take 1 and 2 out again. Okay, so and I will solve this recursively, that I will find the answer for this one separately and I will find the answer for this 1 and 2 separately. Okay, so for this one, the smallest element is again 1, so I add 1 to the answer. Okay, and it becomes 0, so it's 0 0. Now for 1 and 2, so what's the smallest element in 1 and 2? It's 1, so I subtract 1 from 1 and 2, so it's 0 and 1, and I add 1 to the answer. And we have another one left, so I subtract 1 from this one and add 1 to the answer. So if this is the difference array which I am trying to make it to zeros, my answer will be 5. 2 plus 1 plus 1 plus 1. Okay, so this is how do it for the difference array. And for the negative array, it's also the same. Okay, like you find the smallest element. Like one more thing is that in negative array, so let's say if you have a negative array of like -1 -2 -3, you can simply take out the negatives, like you can convert that into 1 2 and 3 and follow the same algorithm which we did for the like the positive sub array. Okay, so is the algorithm understandable? Like kuch dimag mein gaya?
Anish,
Yes.
can you please repeat, please go to the board. Can you please repeat that part? Like we have to first find the minimum one, then we have to add to that minimum one to our answer, and from that minimum part to the left side, we have to do the same thing again, and to the right side also do the same thing.
Yes.
Is it so?
Yes, exactly. That's
Okay,
the
got
point.
it. Okay,
Yep.
okay, got it.
Because you understand, na, there is a pattern which is going recursively.
Yep.
Great. Any other one? Like Aniket, you were telling something.
Anish,
Acha.
hello.
Hmm.
What if in the first array of positive numbers, if we have 3 2 3 2, okay?
3 2 3 2. Yep.
Yeah.
So
Yeah. So yeah, how are you going to divide it?
so first of all, we will subtract 2, so it becomes 1 0 1 0, right? Okay,
Yeah.
so we can take any 0 out here. We can do it like 1 here and 1 0 here, or otherwise we can also take 1 0 here. Sorry, also we can take like 1 0 1 here. Okay, anything will work. Okay,
Okay.
because let's say if you take 1 0 1, after this you will all again divide it like this. Okay, because there is a 0 in between again. Okay, so any 0 you take, it will ultimately boil down to the same answer.
Okay, but how are you going to do this? Like,
So for finding the minimum element in log n time, you can use segment tree. Okay, and
okay.
making the division is very easy in recursive. Okay, so if you see my solution, so first of all I have found out the minimum element in the current subarray here. Okay, and so minimum one contains the index of the smallest element. Okay, and minimum 0 is the smallest element. Okay, so i have taken I have made it into two groups, left and right. So the left one is from the start till the index before the smallest element, and the right one is the index next to the smallest element till the end. Okay, and if there is only one element, I can simply return that number. And if there are like trailing and preceding zeros, so let's say if the subarray is like 0 1 0, I can simply remove the first 0 and the end zeros because they are of no use. Okay, like if the subarray is this, I can simply remove the first zeros and the second zeros because they will not affect our answer, right? So I can simply convert this subarray into 1. Okay, so I'm removing the trailing zeros here, and that's it. That's the recursion, that I would add the left and the right subarray answer and the current subarray answer. Like the implementation is tough. Okay, it's definitely tough. That's why you have 8 points here. Like if you have 5 points, it's tough. If you have 6 points, it's tougher. If you have 7 or 8, it's a very hard problem. Okay. So there are a lot of things that you need to take care of, but the basic understanding is that what I explained till here, that how do you divide into subarrays and then subtract it and then keep on dividing the subarrays recursively. If you have understood till there, you have done a good job. Okay.
Hello, Anish.
Hmm.
Yeah, actually, another thing, like using segment trees, like as far like I know, like we can find the minimum element for
Hmm.
a given range
Yes.
using segment 3. Okay,
Yes.
and after that, what will be the process to find the index and all those things? I'm not that much
No,
versed in
you can
segment trees.
simply do it like this na, like with this. Let's say if the array is, let's say, 3232, with the numbers you can also store the indexes like 3 comma 0, 2 comma 1, right, like this. So when it will return the minimum number, it will return 2 comma 1, right? So with the minimum number, you also have the index of the minimum number.
Okay,
So you can store a pair instead of just storing the array with the index. This will be 3 comma 2, and the last one will be 2 comma 3. Okay, so you are storing the indexes as well with the numbers. So it will return 2 comma 1 to you, the segment tree, right? So the last element of the pair will give you the index of the smallest element, and the first element is the smallest element itself. So using this index, you can divide the array into left and right, as I told.
and after that, like we'll be updating the both the ranges right
Yep.
before going into recursion. Like we'll be reducing like both the like the
Hello.
hello.
Yep.
Yeah, so basically, like we will be finding the index.
Hmm.
Along with that, we'll be getting the minimum number, and after that, we'll be like reducing like the left and the right,
Hmm.
like the parts.
Hmm.
We'll be again updating it like by reducing all the other numbers,
Yep.
like range update, right?
Yep.
For that.
We are not doing range update exactly. Yes, the concept is right. So we are just sending that what number we have to reduce it. So if you see that I am also passing the number I have to reduce it by. Okay, so here you see I am passing what number I have to reduce it by, the smallest element. Okay, so in the next case I am assuming that I have already reduced that range by this element prev. Okay, so that next time I don't have to reduce it. Yeah, it's a kind of range update. You have got the concept right.
Okay.
ओके बट इम्प्लीमेंटेशन लाइक वो तो बैठ के ही पता चलेगा इतना लाइक यू वोंट अंडरस्टैंड सीइंग द कोड राइट हियर यू हैव गॉट द कॉन्सेप्ट राइट ओके so go back and try to implement this. Like it will be hard, like it has 8 points. Okay, cool then. So I think upsolve whatever problems which you couldn't solve. If you didn't solve the fourth one, definitely go and upsolve that. I hope everyone has got the concept right. So now the next part is the implementation one. Like implementation also takes a lot of effort. Okay, so every time I say that if you got the idea, that's only 50% of the work done. Implementation is another 50%. Okay, so those who haven't solved fourth, definitely try to go back and solve fourth. And the first three should be done by everyone. The first three should really be done by everyone. Okay, I think that's it.